Now we're going to move on to a new topic, limits. Now, our ultimate aim is to understand calculus. This here is our ultimate aim, to be able to understand this. But in order for us to understand calculus here, we need to be able to understand limits. Now, calculus is so important. It really gives you a much better insight of how nature works once you understand calculus. Now, a part of calculus is understanding how you can work out the gradient of a function. That's just one part of calculus. So just by knowing the gradient of something, well, the ability to understand the gradient of something really gives you a much better understanding of so many things in nature. Okay, for example, if you want to find out the gradient of a straight line, that's easy, because suppose you want to know the gradient here, you would just draw a triangle underneath here. You would somehow work out this height and then divide it by this height. It's easy when the line is straight, but when the line when it's a curved line, you have to adopt a new concept. So, for example, if you want to know the gradient of this function here at this point A. Now, it doesn't matter if you don't understand this. Just understand it roughly. Okay. If you want to find out the gradient at this point here, which is probably we're going to guess it to be a straight line here. Now, it could be like this, or it could be slightly slopey like this. But at the moment, we're just going to guess it's a straight line like this. Okay, it's a tangent right here, whatever that means, a tangent. Now, in order for us to understand this gradient here, we have to develop a technique, and this is a technique of finding out the gradient at this point here. And the technique is to select another point here, let's say B here. So hang on. So here you would draw a triangle here, a right angle triangle here. The height here would be, well, this point here, remember, this point here would be f of b. Okay, and then, well, your aim is to find out the height divided by the across here. Well, the height here would be f of b take away f of a. Okay, so that this here would be given by this. Well, yeah, if this is f of b and this is f of a here, then the height is f of b take away f of a. Now the across here, we're just gonna, the distance here is b take away a, but we're just gonna call it h. Okay, for simplicity, h here. So the gradient, roughly speaking, the gradient would be b take away f of b take away f of a divided by h. Okay, that's a rough gradient, but it's a really crude gradient. It's not a very accurate gradient. So what you do is all right, earlier b was here. Now you move b to be around here. So forget about this and make it a bit close. So this is well the trick is to make b move closer and closer towards a. So around here our gradient will be something like this. Around here it would be this, and then around here it would be this, and then here it would be this. Well, basically make b head towards a, and that's what limits is about. So as you head towards, well, when b is here, the gradient's here. When b, well, you can see it's getting closer, and well, make b head towards a, and that's what calculus is about. If you make well, the gradient here is f of b minus f of a. It doesn't matter if you don't understand this. And then remember, the across here. Hang on, let's see. The across here is b take away a, but we're just going to call it h. Oops. Hang on, sorry. We're just going to call it h. This distance from here to here is h. So what we do is we try to make this h as small as possible. So make the h to be somewhere around here, as small as possible. Well, that's what limits is about. for example, let me just give you another example. Okay, hang on. Suppose you have a function f of x equals 1 over x, and it looks like this. Well, the limits is about one thing heading towards another thing. So hang on. So up here it would be you wanting to find out the gradient. Well, you start off with your point here, and then this point here is heading towards A. So what you do here, you are really doing this limit of h as h tends to A. Okay, sorry, as h tends to 0. So hang on, bear with me on this, and it doesn't matter if you don't understand it. F of A over h here. So what you do is this bit here is the height of the triangle. Okay, hang on, let me just draw this here. So this bit here is the height of the triangle. Now your aim is to get, you see, you start out here, h here is really big, but as you make h smaller and smaller and smaller and smaller, you really make, remember, h is the distance here, okay, the distance here, and you're making h head towards 0. So you're trying to make this triangle to be really small. So that will give you a better idea of the gradient. And with I gave you an example like this. Hang on. F of x here equals 1 over x here, and remember this function will look something like this. Now you could say the limit of 1 over x as x tends to, let's say, infinity. Infinity is all the way down there. You see, so that means you start, well, you have to start from the left if you're heading towards infinity. So here you're starting here, well, you're moving towards infinity here, and as you move towards infinity, you are heading towards a limit, and that limit is 0. So here the limit here is 0. So it's the idea of the limit here. So it's the idea of it's you heading towards something. So so here let's look at okay, let's look at this side here. Hang on. So here we're going to say the limit of 1 over x here. Now as x tends to 0 from the negative side. Now it doesn't matter if you don't understand this. Just watch a video. So here, well, you basically what I'm trying to say is that I want x to head towards 0 from the left hand side, so from the negative side. So I stick this in here. Now that means I'm starting from the left hand side. I'm heading towards 0. X is heading towards 0. Now as I head towards 0, it's going to go towards, well, it's going to be really big. It's going to head towards negative infinity. Okay, it doesn't matter if you don't understand this. Now, hang on, looking at this again. 1 over x here. So we've got a function f of x equals 1 over x. Now here's another limit. Limit of hang on, let me think. Limit of 1 over x as x tends to 0 from the positive side now. So from the positive side, it's meaning you look at this. As I head towards 0, look at this. Hang on. As I head towards 0, it's going to get bigger, 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 bigger. It's going to head towards infinity, but positive infinity. So I'm just going to say this. Earlier down here, I was heading towards negative infinity. Okay. Another example here is limit of 1 over x here as x tends towards negative infinity. Now x here tends towards infinity. That means I'm moving in this direction. So here, look at this. I start here, and then I'm moving. I'm making, well, x here is heading towards negative infinity. Okay, so yeah, negative infinity. So here the limit here would be, well, it's heading towards 0, because as I move from here, well, I'm moving well, I'm heading towards I'm heading towards 0 as I move from here. Well, hang on. Let me start again here. Hang on. So it's like this. If I start here and move and make x head towards negative infinity, then it's going to head towards 0 here. So I'm heading towards 0 basically. Okay. Well, I will give you more examples in the next video. It doesn't matter if you don't understand this video. Okay.